Now let's try to see whether this non-serial schedule is conflict serializable or not. So conflict serializable means I want to see whether it is conflict equivalent to any of the serial schedules. Now what is the procedure? The normal procedure is find out all the serial schedules possible with these two transactions, and then you test whether it is conflict equivalent to any one of them. That is one method. The other easy method is try to use the precedence graph and get the answer. So what is precedence graph for this particular problem is try to represent every transaction with a node in the graph. Let us say this transaction T1 is represented by this node and transaction T2 is represented by this node, right? Now after finding out the nodes, you try to put the edges based on the conflicting actions, right? Now what are the conflicting actions? Identify the conflicting actions and you can put it. Now if you see this, there is a take every operation here and compare with every operation on the other side, then you are going to get whether it is a conflicting operation or not. Now if you see this, no conflict, right? Therefore there is a conflict and the order is T1 should appear first in this conflicting action, T1's operation is appearing first, then T2. Therefore every conflicting operation should be represented as a edge. So the edge should be from T1 to T2, specifying that corresponding to this conflicting action T1 should appear first and then T2. That is why from T1 to T2. Got it? And again there is a conflict. Okay, what about this? No conflict, right? Okay, for this there is a conflict, right? Again it is also saying that T1 to T2, therefore T1 to T2 is already there. Now there is no need of putting multi edges, okay? And then again, yes, conflict, it is also saying T1 to T2 only, there is already an edge, I am not putting it. Now again for these two, no conflict because it is A and they are B's. Got it? Okay, coming to this, just test with this. No conflict, but this there is a conflict here. Again it is also saying T1 to T2 only, right? Now what about this one? Yes, conflict, T1 to T2, conflict, T1 to T2. Now anyway all of them are going to give me only one edge. Now look at this graph. If there is any cycle, then you can say that it is not serializable, right? If there is no cycle, you can say that it is conflict serializable, right? Therefore this particular non-serial schedule is actually conflict serializable and it is equivalent to, so how to find out the serial schedule to which it is equivalent to is, you just try to write the topological sort of this graph. Topological sort means depending on the directions you can understand it. Now it is saying that first T1 has to finish, then only T2 has to start. That is the meaning of the precedence. Or if you look at this arrow is specifying that T2 is depending on T1, therefore you are supposed to finish T1 first and then T2, right? Which means if you compare this particular schedule with the serial schedule T1 followed by T2, then also you would get the same kind of conflicts. That is the meaning of it. Got it? So what is the procedure that we followed? First thing is we have drawn the precedence graph in which every node is represented by a transaction, and then for every conflicting action I have added an edge. Now in the resulting graph, if there is any cycle, I will say that it is not conflict serializable. If there is no cycle, I can say that it is conflict serializable. Then what is the serial schedule to which it is equivalent to? That depends on what is the topological sort of this particular graph is. Now what is topological sort? Just write the transactions in the order in such a way that if there is an edge from here to here, from one node to other node, then the starting of the edge should be written before the ending of the edge. Got it? Okay. Now why do you think that the cycles will not be able to give us this topological sort is, if you consider a cycle, there is going to be an edge like this, right? Without considering loops. Then what happens is, this edge is saying that T1 has to happen first before T2, and this edge is saying that T2 has to happen before T1. Therefore you can never write a topological sort for it, right? So other way of seeing it is, if you are able to write the topological sort, then you can say that there are no cycles, right? Or better you remember it this way, if there is no cycle, you can say that it is conflict serializable. Okay, fine. With more examples these points will be clear. Now let's see this one. Again the same thing. For this schedule, we want to find out whether this is conflict serializable or not. So every transaction represent it in terms of a node in the graph. Let's say T1, T2 and T3. Okay, and now identify the conflicting actions. So how to identify the conflicting action? For this one, you compare with all the others below it, or all the others from the other side, right? Now if you see this, Rx, no conflict, Wx, yes, there is a conflict. Therefore, it is clearly showing a conflict, and conflict, in this conflict, T1 is appearing first, then T2 is appearing. Therefore, there has to be an edge from T1 to T2. Correct? And what about this one? Compare with this one. Yes, there is a conflict. Now in this conflict, T3 is appearing first and then T1. Therefore, from T3 to T1. Right? And again there is a conflict. In this conflict, T1 is appearing and then T2. Therefore, T1 to T2. Right? And again there is a conflict. Now T1 and then T2. So T1 and then T2. It is already there. Right? Okay. And then this one and this one is already compared, right? So no conflict. Yes, again there is a conflict here between these two, right? Now what is it saying? So T3 and then T2. So from T3 to T2. Got it? So now if you try to see, write what is the topological sort. See, there is no cycle in this. Since there is no cycle, you can say that it is conflict serializable. Now what is the serial schedule to which this particular schedule is conflict equivalent to? So how to find it out is write the topological sort. Now how to write the topological sort is, now see which node I should start with. Can I start with T1? No, because this edge is saying that it is depending on T3. Can I start with T3? Yes. Why? Because it is not depending on anything in the precedence graph. Therefore, I can start with T3, right? And then if you look at this, after T3, you can start T1, but you cannot start T2. The reason is T2 is not just depending on T3, it is depending on T1 as well. Therefore, only choice I have here is, see, initially I had no choice, and then also I have no choice. I have to start with T1 only, right? Because I can't start T2, it is depending on T1. Now T2 is depending both these. So since all of them, both of them are over, you can start T2. So this particular non-serial schedule is equivalent to this serial schedule. Got it? So if you have any doubt, what you can do is write down this the same schedule, or take this schedule and then write it in a serial form in such a way that there will be T3, then T1, then T2, and you just compare the conflicting actions. You will see that they are equivalent. Okay, you can do it as an exercise. Now let's see this one. Now T1, T2, T3, T4. So for each one I have to write one node. Let us say here T1, T2, T3 and T4, right? Now let's take each action and compare with all the other actions. So W of B, no conflict, no conflict, yes, there is a conflict, right? And no conflict, yes, there is a conflict, right? And then no conflict. Okay, so now if you observe this conflict is saying that, in the conflict between these two, T1 has to occur first, then T2. Therefore, from T1 to T2 there has to be an edge, right? Now if you look at this one, this conflict is saying that T1 then T3, right? Therefore T1 then T3. Got it? Okay, now let's see this. No conflict, no conflict, no conflict, no conflict. Look at this. Now this is already over. No conflict. Oh, there is a conflict, right? Conflict, and again there is a conflict with this, right? Now if you look at this conflict, it is saying that T3 first and then T2. Therefore T3 and then T2, right? And then if you look at this one, T4 first and then T2. So T4 and then T2. Got it? And that's it. And since it is a read operation, so is already compared, no conflicts here. And again this is the read operation, read and write. Yes, there is, okay, you didn't compare this one, right? So this one no conflict, but there is a conflict here. Now this one is saying that T3 first and then T2. So T3 and then T2, it is already there in the edge, right? Now again this one, if you compare with this, no conflict, right? So this is the graph we got. Now from this graph you can say that since there are no cycles, you can say that this graph is clearly this schedule is clearly conflict serializable. Now what is the serial schedule to which this schedule is equivalent is, you just write the topological sort of it. Now what is the topological sort here? Can I start with T3? No, because T1 is it is depending on T1. Can I start with T1? Yes, I can start with T1, or if I have any choices, if you see this, I can't start with T2, but I can start with T4. Therefore I can either start with T1 or T4. Based on that you might get two serial schedules to which this particular non-serial schedule is equal, or more. Let's see how many we get. Now one order is T1. Now the other order maybe I could even start with T4, right? Now after T1, can I start T3? Yes. Can I start T2? No, right? But can I start T4? Yes, I can start T4. Therefore we are getting many serial schedules, right? So after T1 I can start with T4, or after T1 I can start with T3, but I can't start with T2, right? Now let's see what happens with this. So T1 followed by T3. Okay, T1 is over, T3 is over. Now can I start with T2? Yes, so I can start with T2. Or can I start with T4? Yes, isn't it? Therefore after T1 T3 I can start with T4 or T2, isn't it? After T1 and T3 I can start with either T2 or T4, isn't it? So now let us say we have considered this order. Is this order possible? T1, yes, and then T3, yes, and then T4. Now all these three are over. Okay, now is this possible? After T1, okay, let's see this one. So all these three are over, then T2 I can go for it. So this is a, now here if you observe this, T1, after T1 and T3 I cannot start T2 because T2 is depending on T1, T3 and T4, all of them. Therefore this one cannot come. Okay, so only order possible is after T1 and T3 I have to finish T4 and then T2, which means it is also going to lead us to the same one. There is no need of it. Now what about T1, T4? After T1 and after T4, can I start this one? No, I have only one choice. I have to start with T3. Yes, T3, and then remaining one is T2, right? Now if I have to have started with T4, then after T4 can I start with T3? No. Can I start with T1? Yes, there is only one choice there. Now T1 and T4 are over. Then can I start with T2? No, I have only one choice, which is T3 and then T2, right? Therefore these are the three serial schedules to which this non-serial schedule is equivalent to. But then if the question is about finding out whether it is conflict serializable or not, just draw the graph and see that there are no cycles and stop there and say that this one is not this one is conflict serializable if there are no cycles, right? Now if they ask you in particular about how many serial schedules it is equivalent to, you might have to write all of them. Or if they ask you about which of the following is a serial schedule which is equivalent to this non-serial schedule in conflict, then you will have to look at this graph and see the order if it is possible or not. Got it? Okay.